So our goals for today are to be able to write equations of any parabola that we're given, no matter what the form is. So we are going to be starting down here in the middle of page 41. What if we're given a point and we're given the vertex? Well, if we're given the point and we're given the vertex, we're going to plug our vertex in here. That's where our vertex gets plugged in. And then for x and y, we're going to plug in our point. And if we do that, then we should be able to solve for a. And then we're just going to rewrite the equation with h and k in it. Questions on that? We could also be given the x-intercepts. If we're given the x-intercepts, those are going to get plugged in here and here. And then what's going to go in for x and y? What's this? Point, right? So the point's going to get plugged into these spots. If we are given 3 points and one of them is not HK, we're not going to do this. This is a way it could be done, is to solve a system of 3 equations and 3 variables. Do you remember when we did that though and how long it took? So we're going to do instead, anytime this comes up where we're given 3 points or more, we're going to use the quadratic regression on the graphing calculator. Because that's going to be lots faster and more efficient and just better. Okay, so those are the 3 ways that we have that we can write the quadratic equation. All right, go over to page 42. We're going to jump right into some examples. So let's take a look at number 2 in your student journal on page 42. So I want to identify which method I'm going to use. Well, what is this point right here? This is the what? Vertex. So I've got the vertex. So I've got h and I've got k. This is just any other point. So this is going to be x and this is going to be y. So then I have to think back, what form do I use when I have the point and the vertex? Vertex. I'm going to use the vertex form. So this is going to be y equals a times x minus h squared plus k. So I look at my list here. I'm going to put in y is 1, a I don't know, x is 2, h is 0, squared plus k is 3. Solving this, I have 1 equals 2 squared is 4. Put your a there too. Plus 3. No, it's plus 3. It's 4 times a plus 3. So now I'm going to subtract 3 from both sides. I have negative 2 equals 4a. So a then is going to be negative 2/4, which is what? Negative 1/2. So now I can rewrite my equation. Y equals negative 1/2 times x, and it's just going to be x squared. I can put x minus 0, but that's just x squared. So it's just x squared. Get rid of that parenthesis. And then plus 3. I'll rewrite that a little neater. That should be our equation. Now, if I'm taking a test, I would like to make sure that this is right. I'm going to show you a way that I can do that. So if I want to check this, I can just put this into my calculator. Negative 1/2 x squared plus 3. If I want to know if these points are right, where's a quick way I can do that? Go to what? No, that's how I put in a bunch of points. I actually want to go to the what? Okay, I can do that. Second trace, calculate a value. And I should have done it. When x is 0, y is 3. I can check my next point, calculate a value. When x is 2, y should be 1. It is. That's not the way I would have done it, though. I would have just gone to my table, because it's much faster to just go here if I want to check a couple of points. I can see my point 03 and I can see my point 21. That's where I would go. You were thinking of the table, I think, when you said stat edit. Everybody got that? You should never miss those kind of problems when you can check them. All right. We're not going to do any more. Both of these two are the same type with a vertex and a point, vertex and a point. I don't think we need to practice more of those. We've done those in the past. All right, let's go ahead and let's review one where we have an intercept form. Let's go down here. Let's do the more difficult one. Let's do number 8. Do 8. All right, so they're giving us the x-intercepts. Here they're showing us the x-intercepts. So we look back at our form. It's y equals a times x minus p times x minus q. I'm going to be subbing in for my x, for my y, and also for the p and the q. Can anybody tell me how to set this up then? What am I going to plug in for y? Everyone? 27. A we don't know. What are we plugging in for x? Minus 7. And then I have another x. It's the same x, negative 7. And then minus what? 10. I did? Sorry, negative 2. All right, so now I'm going to do all this math, this arithmetic. Negative 2 minus 7 is negative 9. So I have a times negative 9. This is negative 12. And so now I've got 27 equals negative 9 times negative 12 is 108a. So to solve for a, I have to get rid of the 108 by dividing. Now simplifying this, if I see 2 and 7, those digits add up to be 9. These digits add up to be 9. Did you guys know that divisibility rule? Okay, so this can be divided by 9, that's 3. This can be divided by 9. Here's how I can divide it quickly. 10 divided by 9 is 1 with 1 left over. 9 goes into 18 12 times. So this is going to be 3/12. 3/12 is just 1/4. So therefore, I'm going to have y equals 1/4 x minus 7 times x minus 10. If I wanted to check it, I put it in my calculator. Where's the best place to look? The table. Now, guys, I want to show you another form you might see this in, especially in pre-calc next year. They may tell you, no, this is the answer that I want. See if you can understand how I'm getting this answer. And would you be able to get this answer too? I did that really quickly, but can you see how I got that? Yep. Yep. I multiplied it out, and then I multiplied it all by 1/4. So I did that all at once. I don't expect you to do that, but this is the answer we're going for, but just recognize that these two would be equivalent. Okay? All right, let's go back here to the back. Page 43. Analyze the differences in the outputs to determine whether the data are linear, quadratic, or neither. If linear or quadratic, write an equation that fits the data. Okay, we're not going to do this part because we're going to do this part on the last one. But we're just going to identify whether they're linear or quadratic or neither. Here's what they mean. If the first differences are the same, it's going to be linear. If the second differences are the same, it's going to be quadratic. If the third differences are the same, it's cubic, but we're not going to mess with cubic for right now. All right, so what I'm going to be looking at is, what's the difference here? To go from 424 to 416, I would subtract 8. To do these two, I would subtract 40. To go from here to here, I would subtract 72. To go from here to here, I would subtract 104. To go from here to here, I would subtract 136. Those numbers are not all the same, so therefore I know it is not linear. But it might be quadratic, so I'm going to look at the differences of the differences. Okay, so to go from here to here, I would subtract 32. To go from here to here, I would subtract 32. Uh-oh, looking good so far. Here to here, subtract 32. Here to here, subtract. That one doesn't work, does it? Is that subtract 32? Yeah, it is. Oh my gosh, what am I thinking? Subtract 32. So our second differences were the same. So what's that going to be then? Quadratic. And so then you could put all these into L1, L2, and run a quadratic regression on it. But we're not doing that for time's sake. On number 10, we're going to find our differences. Now the first thing we have to check is make sure the x's are spaced evenly, and they are. So now I'm going to check my differences. Here I would subtract 6, subtract 6, subtract 6, 43. Keep subtracting 6. So what's that going to mean? If those first differences are the same, this has to be what? Linear. And this is exactly linear because all of these differences were the same. This one is exactly quadratic. See, most of the data we get is not exactly quadratic or linear, and that's why we have to use our calculator, because the slopes, the calculator figures out the average of them, but that's linear. So what would our r squared value be then if it's exactly linear? Anybody remember? 1, it'd be exactly 1, yes. All right, so we got that. And if I wanted to find this equation, watch how quickly I can come up with it. I'm looking at the slope. What's the slope? Can you tell the difference? It's not -6. It's actually, no, the difference in the y's is down 6, but what about the x's? If I do my slope, guys, 30 minus 36 is -6. 3 minus 0 is 3. So what's -6 over 3? So it's -2x plus, what's the y-intercept? 36. So I could get that equation pretty quickly. All right, now this is the one I definitely want to look at. So take a look at this. It says the table shows a university's budget in millions of dollars over a 10-year period, where x equals 0 represents the first year in the 10-year period. Part A, use a graphing calculator to create a scatter plot. Which better represents the data, a line or a parabola? Your numbers may be different on that one. It's okay. Just go with what I have, okay? Because they're different student journals. It's a different version. All right, guys, so here's what we're going to do. We're going to put these in under our stats. This is when we do the stat edit. We have to go up to the top and clear out anything we have. It's just the one problem. So now we're going to put in the x's. We're going to go over here. We're going to put in the y's. Make sure you have the same number of x's as y's. Now, a couple things I have to do to be able to see these points. If I just hit graph right now, I'm not seeing much of anything on mine. One thing I want to do is I want to go to y equals. I want to clear out anything I have in there. Another thing I have to do is I have to turn on my stat plots. Right now they're off. I need to go up here and push enter to turn them on. The other thing I have to do is I have to change my window. My x's are going from 0 to 9, so I might want to go from like -1 to 10. My y's are going from like 0 to 150. I might want to go to just to 200. Now when I look at these, there's my points. Okay, here's the first point. Does it appear to be more linear or more quadratic? It's not exactly either one of them, but it's more what? Quadratic. Here's how I can tell which is better. Let's all go to Stat, Calculate. Let's test it for linear first. I'm going to go down here just quickly to calculate. Look at the r squared value. So to check to see if it's linear, the r squared is 0.82. Now I'm going to run a quadratic on it. So I'm going to Stat, Calculate, Quadratic. I'm going to go down here and calculate. And the r squared here is 0.88 for quadratic. So which one was the better? Which one's closer to 1? Quadratic. So this is going to be more quadratic. Okay, so now I'm going to go back, Stat, Calculate. I'm going back to quadratic. I'm going to tell it to put that function into y sub 1. So I go to vars, y1. Now when I go to calculate, now it's going to put that in there for me. Y equals, or not y equals, Stat, Calculate, Quadratic. Where I want it to store, I go to vars, yvars, enter, enter. It's telling it to store into y1. Then when I calculate it, and I go back to y equals, it put it in there for me. And so here's the parabola that best goes through those points. It's not exact, but there's as many below it as there are above it. And a couple of them are even on the parabola. Wait till I'm finished and I'll help you. So here's our parabola. And we're going to write down the one that we came up with. I just want to see it one more time. Okay, so I'm going to round to the nearest thousandths place to make it more accurate. So that's 3 places after the decimal. So 1.492x squared plus 0.508x plus 39.982. That's going to be my equation. Now it says use the model in part B to predict when the budget of the university is $500 million. Do I want y to be, am I going to put in my calculator 500, 0.00000? No. These are in millions. So what do I want my y value to be? 500, not 500 million. That would be 500 million million, which I don't even know what that number is. So let's go to y equals. We're going to go down to y2, and we're just going to put in 500. Now, when I hit graph, I'm not even seeing y equals 500. Why not? Because the y max, right? I need to go to my window. I need to make my y max bigger than 500. I'll make it 600. Now when I hit graph, there's my parabola. There's when y is 500. Well, it's not going to happen for a long time, is it? So I need to go down a lot further. So I'm going to have to go back to my window, and I'm going to have to extend this maybe to 25. So here's my parabola again. There's my y equals 500. What am I trying to find now? The point of intersection. So second trace, I'm going to go down to intersect number 5. Let's get close to that point of intersection. Enter, enter, enter. And there we go. After 17.4 years, we'll run to the nearest 10th. So 17.4 years. It'll be 500 million. Okay? Questions on that? All right. So we're looking at all those different forms that we can use. We've got the vertex form. We've got the, and you know what? There's even one more form. Let's add on our one last form. Our other form that we haven't talked about in a while is standard form. Standard form is this: y equals ax squared plus bx plus c. And that form right there, you would have to know an awful lot to be able to solve for a. You'd have to know x, b, c, and y. So that's not going to be used very often to solve for a. All right.